So after running 300 seconds, the solver finished running all the 500 steps. I make a screenshot of here. So this is current running after using third-party meshing software, and this is the previous. So execute time is 900 seconds, and the convergence become difficult. But now I can finish all the running within 300 seconds and all the times running. So that means the third-party meshing really give us a better solving process compared to the SnapX mesh at this stage. I believe there will be some reasons behind the quality of the mesh. And now I'm more interested comparing the results, so how the results compare with between the two. So to do that, I will just operate my SnapX mesh. So this is my current. So this current I call crystal foam. So that's the current using the third-party software to get the results. So I will refresh it, and hopefully it will give me the results of the 500 steps. That's true. So I apply it again, and this is if I see the temperature, I will see there will be the evolution until the final stage. But I want to compare with my previous results, so I go to my previous folder and find it and compare with this. So my previous called macro.he.foam. So I load this foam again and I apply it. Because it's currently overlapped with each other, so I need to move a bit to the different positions. I'll move it up just to be more identified by the comparison. So I will use transform of this by moving it along the y directions. Let's see, 0.15. So yeah, so again, this is old by using SnapX mesh. I'll apply it, and this is the current one using the third-party software, right? So that gives me some. I will finally go to the final results, and definitely give me some like differences between the two simulations. So I just make sure for the macro.he, I also only choose the air and water internal mesh only. So remember, this one is for the SnapX mesh, and this one is for the current mesh. Okay, so I'll go to the final step. So generally speaking, they are quite similar for both. Right, so the general temperature field is very similar, only a bit difference here. So the new mesh give us some plot which is kind of a thermolocal high local region, high temperature region here, but not found in the previous one of the macro.he or the SnapX mesh. So that is what I plotted here. And also, if you want to compare the outlet, so the outlet means we want to compare what is the temperature really along the outlet. So I will use a tool called plot over line. Plot over line. I will plot line on here, which will be the interest point at the intersections of the middle region of the outlet. So the coordinates I actually used is minus 0.2, minus 0.065, and 0.006. So I will use this as, so it's actually minus 0.006. So that should be give me and I use minus 0.15 and minus 0.065. I use copy here, so that's along the x direction, right? So that's only along the, so I need to see minus 0.006 for here as well. So that's actually a line along here. So maybe this is not so correct. 0.006. That would give me the correct direction, right? So that is a plot over line for the current mesh, not so exactly along the center, but it's very close to the center of the middle line. So I'll apply here. So it will give me the results of different plots, but I'm only interested in the temperature. So this is temperature distribution, right? And for this one, I also need to define a line along the same position, right? So along the same position by using the plot over line, and the position I'm interested is still the minus 0.2, but because I elevated or shifted the y, so now the y becomes 0.085, right? So 0.085, and it's still minus 0.0006 if I still remember well. So that's it, and that's it, and it's minus 0.15. So yeah, so this is the position for the SnapX mesh. I will also use the plot over time for the both, and this time I also plot the temperature only, but for temperature I use a dashed line. So dashed line to indicate this. So I clearly see the difference, right? So the solid line is currently the results by using the third-party software, and this dashed line is by using the SnapX mesh. So which means, because I didn't have a viscous layer clearly defined, but here for this example I actually use a viscous layer more refined at the boundary layers along the wall. So you can see this will be more closer, it's closer to each other. But for this one, I didn't define the viscous layer or the boundary layers, which means it gives some like predictions a little bit shifted with the previous one use SnapX mesh. But anyway, you can always change the mesh, here. So if you change the mesh by introducing more refined regions along the wall boundaries, you might have a better solution compared to the current one. Okay, so that is end of all the CHT for the intermediate. So that is construct complex mesh by using two different methods, built-in tool and also third-party tool of the pre-processing software packages. So hope you like it.